Our system is the wagon plus the grain. No external forces act on the system, and therefore we can apply the conservation of momentum in the x direction. The grain has no initial horizontal momentum. Therefore, the initial horizontal momentum of the system is just equal to the mass of the freight wagon, 14,000, times its velocity, which is just 4 meters per second. The final horizontal momentum is equal to the mass of the freight wagon plus the mass of the grain that has been dropped. So that's 14,000 plus 2,000 times the combined final velocity Vf. Applying the conservation principle, making the initial momentum equal to the final momentum, we get that the final velocity Vf is just equal to 14,000 times 4 divided by the total mass, which is 14,000 plus 2,000. The time taken to travel from the hopper to the yard is just equal to the distance over the velocity, which is 500 over Vf, and therefore equals 500 times the total mass, 14,000 plus 2,000, divided by 14,000 times 4. And that works out as 143 seconds. Suppose now that there is a hole in the bottom of the wagon so that the grain leaks out at a rate of 10 kilograms per second. Now, how long does it take for the wagon to travel the 500 meters? Pause the talklet here so that you may consider your answer and then restart it when you are ready. The answer is 143 seconds. Can you explain why? Again, pause the talklet and give yourself time to think about it and then return when you are ready. Mass of the wagon plus grain is decreasing. However, the velocity of the grain in the horizontal direction after leaving the wagon is identical to the velocity of the wagon. And therefore, the momentum of the system, in other words, wagon plus grain, does not change. The grain does change its momentum when it hits the ground, and there is a resulting force on the ground, but that does not affect the motion of the wagon. If the ground were frictionless and flat, all of the grain initially in the wagon would arrive at the yard along with the wagon.